Welcome back. Today we're looking at section 2.1, functions and their graphs. We're going to do some review again. It's going to be the value of a function. We're talking about domain and range, and we're looking at interval notation. You're probably going to want your calculator, so if you don't have that, you want to go ahead and pull that out at some point in time. So we've done values of a function. We've done this quite a bit. Way back in Algebra 1 we started this. So if I give you the function f of x equals x squared plus 3, can we find f of negative 1? And remember, f of negative 1 tells us that x equals negative 1. So we're going to take that negative 1, replace it wherever we see an x in the f function. So we have negative 1 squared plus 3. We can go ahead and simplify this. Negative 1 squared gives us 1 plus 3. That gives us 4. And so our answer is going to be 4. What I'm more interested in is that we can find something that's not necessarily a numeric value. So if I give you, or ask you to find f of a, so to find f of a, again, they're telling us that x equals a. So we're going to take where we see an x and replace it with a. Not too bad, huh? So we get a squared plus 3. We can't do anything else with that, so we leave it. It's okay that we don't get just a value. We're interested in being able to find a manipulation or finding a algebraic value of that. So to find f of a plus h, this gets to be a little more complicated because now they're telling us that x is going to equal a plus h. So again, we're going to the x function, replacing it, all the x's with a plus h. So I have a plus h squared plus 3. And I am going to ask you to be able to simplify this. So we want to go ahead and square out a plus h squared. In order to do that, there's a couple ways you can do it. You can come off to the side and do a plus h times a plus h, and then distribute the a, then distribute the h. If you had a good Algebra 2 teacher or pre-calculus teacher, they probably showed you the trick of squaring the first term, multiplying the two together, and doubling it. So a times h is ah, doubling that gives us 2ah, then adding this last term squared, so plus h squared. That's to square out a binomial. Then plus 3. And there you go. We get a squared plus 2ah plus h squared plus 3. Not going to do anything with that at this point in time, but later on things will happen. So domain and range. If you recall, the domain is the x values, while the range is the y values. So we're asking, if I ask for the domain and range, what are all the x values that we could plug into this function to get something out? X plus 5, that's a linear function. So if we look at the graph of that, we're coming up here through 5. We have a positive 1 slope, so it's going to look something similar to that. So are there any x values that we can or cannot plug in and get something out? And hopefully we see that this continues on forever in both directions. So we'll be able to get any x value on that graph. So our domain, in this case, is going to be negative infinity to infinity. And this is our interval notation. Recall that when we're working with infinity, we can't touch infinity. Infinity doesn't exist as a number. So we show that we cannot touch it by putting it in parentheses. If we could touch it, then we put it in brackets. Our range for this function, again, we're looking at the y values, so we draw a horizontal line there. Can we touch the graph at any y value that we're given? And again, this goes on forever in both directions, so we know the range is negative infinity to infinity. In the second part of this example, we're looking at f of x equals x squared plus x minus 1. Hopefully, again, we see that this is a quadratic function, and we know a quadratic function is in the shape of a u. So it doesn't matter where this is on the coordinate system for our domain. We'll always be able to come up and touch the graph at any x value. So our domain is negative infinity to infinity. Again, non-inclusive. But what we're going to do then to find the range is get out our calculator. Go ahead and quit out of there. So we're going to graph this. If you recall, again, y equals, we're going to type in x squared plus x minus the 1. Again, your x value, your x variable is next to the alpha button there. If we graph that, so now notice we can come to this point upwards in order to find our range. Our graph does not exist down here in this part. So we want to find the lowest point that this will come to. In order to do that, we can do our second calc. We're going to look for a minimum value. Since our parabola opens up, we know we have a minimum value. It's going to ask for the left bound, so we can move that cursor using our over arrow, or you can type in a number to the left of it. So you could type in maybe -2, -3 there. For the right bound, again, you can move your cursor using the right cursor button, or you can type in a number. Looks like 2 would be much farther over than we need to. Then you can guess. Here I just hit enter for us to get a guess. So we get x equals -0.499999999 and y equals -1 1/4. So our range, remember we're looking for the y values, so we can go down to -1 1/4, -1.25, and we can go all the way up to infinity for our range. Notice it's inclusive because we can touch at -1 1/4. We're exclusive with the infinity because we cannot touch infinity. I have one more example for domain and range there, and this is going to be a radical. You probably should be able to graph this without the use of a calculator, but in here you can be able to use your calculator for pretty much everything. So we'll go ahead and show you what that's going to look like. We're going to type in the square root of x plus 1, and then we're going to subtract 2 from that. If we graph it, we see that this graph is starting at this point here and it's continuing up. If you recall, again, that should be at -1, -2. We take the opposite of that x of the number with x, that gives us the x coordinate, and the number by itself gives us the y coordinate of that vertex or that starting point for a radical. So our domain, in this case, we're going to start at -1 and it's going to go to infinity. It's going to go out forever in this direction. No x values out here. No. I'm going to mark on my calculator. And I'll clean that later, I guess. We'll see how long it takes me to clean it. So the range then, our y values, we're going to start here at -2 and we're going to continue up. It's continuing up ever so slightly, but eventually it will go all the way up. So our range in this case is going to be -2 to infinity. Again, we use the brackets to show that we can include it, it can touch. The parentheses show that we cannot touch or it's exclusive. Good luck.